Hi, my name is JF and I'm from Bot Factory, and today I'm just going to go through a quick demo of how to print something with Squink. Right now I'm here connected using a Wi-Fi router, and all I had to do is type in squink.local/home, and here I am on our front page. It shows you everything you need. You want supplies, you want to have any questions, there's a forum, and of course our news. And what is going on? Yeah, we got to make sure our video is up and running. You can see that right here. And we're going to go through every single step. The first step you do is click on Start New Print. And what happens is Squink asks you to upload your outline, which is a GTO. It can also be an image like a JPEG or a PNG, but you have to upload it by simply drag and dropping or going to your file and selecting the right one. Here we are, GTO, that's exactly what I want. And since Squink has an embedded computer into it, there is no required processing ongoing inside your own computer. Squink does everything itself. The second step for printing the traces, which is what we're doing right now, is you need to upload the top layer. Top copper, basically the single trace file that you're going for. If it's a picture, sure, why not? It has to be the same image that you used for your GTO. Basically, your GTO is your outline. So if it's a 200 by 200 pixel image, you have to upload 200 by 200 pixel image, which is the trace image you want to go with. And the second image essentially is your layer. It's the same file. Here we are. This is the design that I'm working with. It's a very simple circuit. I'll show you how it works when we're done. But here we are. Basically, Squink shows you all the top copper, the tool path, where the ink's going, the outline, everything you need. And I'm pretty happy with what I see here, so we should move on to the next step. That includes attaching your inkjet head. Now, we have the cartridge attached to the tool head. I have to remove the tape that is over the set of nozzles. That is to prevent it from drying out. Simply attach it, and then I take my DB25, which is this guy right here, and connect to the top. Ta-da! Alright, so we're done with that. Move on to the next step. Now, you see here I already placed some paper, which is photo paper, which works with our standard ink glues, conductive inks. If I was using FR4 or anything like that, it doesn't really matter. I would still tape it down with blue tape. You can use Kapton tape, really anything that can survive about 120 degrees Celsius, which is how much heat we use for our glue curing process. I want to align the head more or less with my top left corner of the traces, the design that I'm going to print. But before I do that, I'm just going to run a quick nozzle test. I want to make sure that my cartridge is primed to print, that there's no clogs or anything like that in the nozzles. And no problems at all. It printed perfectly well. You see this pattern here? Basically what happens is it discharges all the ink out of all the nozzles and then tests one. Test 2, 3, 4, 5, all the nozzles. And if there's any nozzles missing, you can remove them from this list right here, and Squink will figure out the new tool paths and then print with that. So it's possible to print with one nozzle if you really have broken them all, but this rarely happens. Usually every single nozzle works fine. The problems are usually due to ink clogs, dry ink. Now you can remove that by using your deionized syringe, deionized water, which is in a syringe that we provide, and a little piece of paper. We use industrial strength bathroom tissue. It works great. Essentially wet the nozzles and then pull the ink through using capillary action with the paper. So I'm aligned the inkjet head in the correct spot, so I'm ready to go on to the next step. And what happens here is very, very simple. Squink is first going to print off another test pattern to make sure all the nozzles are ready to go. Then it's going to print two X's above the traces that we're going to be printing. Those X's are used to align the other two heads, the glue head and the pick and place head, so that we can actually align everything on the right spot. The glue is placed on all the solder points, parts are placed in the right, positions, and that we are, as they say, hunky-dory. Now you can see in the preview that's going on right now that Squink essentially is printing off one trace and then slightly moving laterally, or up and down rather, to make sure that there's multiple layers being applied. This ensures that there are no opens in your traces. It also ensures that you're going to be able to reach the maximum connectivity of the traces that you have. Now, I made all these trace widths about 30 mil, which is about 0.75 millimeters. You can go as low as 10, but you have to make sure that the angles of each trace is multiples of 45 degrees. So if I made all these trace widths 10, this would be acceptable. It would be printing. It would have been printable, and there wouldn't have been any opens or anything like that. Now, if you use 20 or 30, you can do any kind of angle you want. 22.5, who cares? But you can't do that with 10 mil traces. It leaves too many opens. So keep that in mind when you're designing with your Squink. And look how fast it's being done. I mean, imagine sending this off to some PCB vendor. It'd take you forever to get even this simple design back. Or, doing micro milling using an open mill or any of one of those milling machines. I mean, making isolation circuits is noisy and fairly frustrating. You have to get the copper clad boards and go from there. Photo paper is easy to find and works great. On the plus side, you can also make flexible circuits, and all for the cost of a cup of coffee and a little bit of your time. And we are nearly done. Voila! Here we go. So I'm happy with this trace. I don't see any splatter on the side. It has very sharp definition. There's no opens that I can see of. I'm sure it will actually conduct quite nicely. So I'm going to go to the glue step. Squink asked me to detach the glue head, the inkjet head, and I put that aside. Before I put it aside, though, I place the tape back on the nozzle so I don't have to go about unclogging it later. DB25 connector out of the way, and upload my solder mask file. Now, you can also upload images, as we said before, but it has to be the same size and only define the solder pads, not the whole circuit or anything like that. You can also take a GTS or a GTP. These don't really matter. I'm going to drop the GTP because I just want to solder place the glue on all the pads. Squink takes the file, calculates all the tool path movements based on the size of your pads. Basically what happens is Squink is going to place dots on all the pads and place more if the pads are larger and fewer if they're smaller. So you can see one dot for all these resistors, this transistor, but for the battery holder it's going to get more dots, more glue, easier, it's going to attach better. So I'm happy with this. I don't see any issues. Yeah, we can go from there. So I take this glue head, which is just a linear actuator and a syringe full of 2-part glue, and I attach it here. Then I take my DB25 connector, plug it in, and click next. Okay, so I've inserted the syringe. Now you have to move this guy up and down to make sure that the syringe fits in there quite snugly. But I've already done that, so we can go on to the next step. Select your materials. Now, I've been going with about 3.5, but that's because I like to have a lot of glue. My parts are fairly large, but you can use less, you can use more. If you're using paste or other types of glues, you can really choose any kind of setting you want. We made this as easy as possible for you to experiment and try using different materials. Or, place more solder or glue or what have you. So I'm going to go with this, 3.5, and then it's going to ask me to get the glue flowing. And the glue is not really flowing because it's been sitting by itself for a bit, so there's no pressure inside the nozzle. And there we go. After one click, I can see quite a bit of glue coming out already. So this guy is pretty much ready to go. So we wait for it to finish, and then I click on next. Now I have to align the tool head with one of those X's that I was talking about. In this case, the lower X, this guy right here. And I have to use the keypad to line everything up, and Squink very nearly managed to align it all by itself, line the whole tool head by itself. But I just have to make some minor adjustments here. To make sure everything is hunky-dory. And I'm pretty happy with where it's positioned. If you get it off, I mean, you're going to have issues. You might cause a short or something like that when you're finished your design. So spend a little time to make sure it's lined up perfectly. Now you can see, just like our jetting, our path before, you can actually toggle different settings, different parts, different layers more or less of what's going on. So, and you can see a Squink immediately tells you which one it's going with. And I'm looking at where it's placing, and I'm extremely happy with where it's depositing every single dot. Yep, definitely. Now, is it applying enough glue is another question. I have to take a closer look here. Oh yeah, it's placing more than enough glue. Now, if I wasn't terribly happy with the amount of glue or the setting that I'd used, I can always go back and reset that, try a different setting, and maybe apply more glue, run it again, that kind of thing. It's really up to you, and if you want to get, how you actually get there. We want to make it as easy as possible for you to kind of experiment and try to perfect the kind of circuit so that you're able to basically take almost any circuit and then print using Squink. The process is so reliable, though, it's fairly easy for you to just walk away, grab a cup of coffee, talk to a colleague, that sort of thing, and then come back and everything's done. When you think about how difficult it is to make a solder mask or get one made, and then essentially squeegee on all that glue. It's difficult, and it's time consuming, and it's really just a waste of your time. You should be designing and innovating and fearlessly thinking about new ideas and things you can make with Squink, while it's essentially physicalizing your ideas. Voila, we're all done. So let's go on to the next step. As soon as Squink is essentially done wiping its nose, so to speak, that's what the foam here is for, essentially to make sure that the syringe tip doesn't have any buildup of glue or anything like that. So go on to PNP. I'm happy with what I see here. I was watching it earlier and it was extruding all the glue I needed. So I'm going to detach the glue head and go to the next step. Alright, now this is a .csv file. It can be a .tsv file. These are exported from Upverter, but you can export from Altium or KiCad, whatever. But essentially, it's just a centroid and rotation file. XY coordinates and the amount of rotation expressed in degrees. So I upload that file. It's also going to calculate footprints based on the information. Is it 1206? Is it so on? Is it SOT 23? That kind of thing. And with that information, Squink will be able to calculate essentially how to place every single file. Right now, what's going on is Squink is thinking about the file and seeing if it's actually going to be the kind of file that it can actually pick and place. And the beagle bone fucking died. I cannot believe this. There we go. So it looks like we hit a little hiccup. And now it's asking me... Okay, so we seem to have hit a little hiccup, which happens. And I'm going to try this again. And voila, no problems. So, that was interesting. Occasionally this happens. I think things got a little confused. It may have been actually a router issue, because nothing seems to be wrong with the actual machine itself. Didn't crash or anything like that. I think what happened was a router error. But no biggie, works fine. So these are the original headings of each column, and this is what the headings that Squink is expecting. So it's making some guesses about which is which, and I'm happy with what I see. Ref-des means designator, comma means comment, x, y, essentially it knows what it's dealing with. So I'm going to say that's my file, and go to the next step. Now, Squink is also going to ask about what the footprint size is and if they're correct. And these all look fine to me, so I'm pretty happy with that. And of course, if it has a few footprints it's not familiar with, it's going to ask you for the information. Basically expressing, hey, what's the length, what's the width, are we okay with this? And then I say, yes, these are what the widths are. Then Squink can essentially go on to the next step. Now, I have to attach the pick and place head, this guy. So I drop it into place right here. Put the DB25 connector in, attach the vacuum hose, which is the black hose right here. And before I actually hit next, I want to make sure this guy's lined up center line, because it's going to be rotating a lot, and I want to make sure that it's centered when the motor's activated, like it is now. Now, it's important that I make sure this whole guy is centered, and it looks very centered. I've been using it earlier today. But what you want to do essentially is move it around so that it's aligned with the bottom right corner of the tray. Not too difficult, but once you have that all set up, then it will know where to place the pickup head, the pick and place head, and find the center of each part in each slot. Right, now I have to find the XY coordinate of my file, which is right here. There we go. I'm happy with that. The old pick and place, attach the shield. This guy is more or less the world's smallest green screen, and we use that for detailing the outline of each part when we pick them up. We'll see that in a second in this video. So Squink is going to go right in front of the camera and take a picture, and you'll see exactly what I'm talking about. So, you see in this picture right here, it's used our computer vision software to identify the tip. So once it knows where the tip is, it's able to calibrate a correction, or create a correction if it picks up, say, the part on the corner or the side instead of the center of that part, which you'll see in a second. That's basically how most pick and place machines work. We've just managed to miniaturize it. So I'm happy with this, so I'm going to hit auto skip. You can do auto calibration, which just does a few number of tests to make sure the calibration goes. The pick and place head's going to the right spots. But in this case, I didn't really need to. If you're calibrating the machine, it's important to do these kind of auto calibration steps. Now, I have to assign slots to each part using this reference tray. So if I have parts, and you can see in the video, I already lined up some parts in slot 0, 1, 2, 3, and 4. So I have to essentially place or tell Squink where each part is in which slot. So U3 is the phototransistor, which is this tiny guy here. So I'm just going to say 0. R6 is my 280 ohm resistor, and this guy is sitting right here. And so I'm telling him he's in slot number 3. D1 is my LED, and I have to make sure, because it's actually a diode, it's got polarity, I have to make sure that the diode is facing into the slot and to the right. That's really critical. Just like any pick and place file that comes with, if you send out to PCB vendors, you want to make sure that alignment is there. So I checked that, and that's true, and it's in slot number 1. R1 is my 100K resistor, this green guy here, and he's all lined up. He has no polarity, but he is number 4. Yes, number 4. And U1 is my NPN transistor, which is this guy here. And he's lined up, and he's happy, and he's in number 2. If there's any, for example, if there's any conflict, you'll see it. I like that aspect of Squink, how it kind of thinks ahead. So I'm ready. So we're going to go and click assemble. And there we go. Picks up the part perfectly. That's the smallest part. I picked it up right in the center. Takes a picture and makes sure that the whole part is aligned with the footprint alignment. And I think now, oh, placed it perfectly. Perfect. I love it when that happens, which happens nearly all the time. It's always a wonder to watch Squink work its magic. I love how the camera just manages to do the smallest alignments to make sure it's perfectly straight. These are 1206s, and we find that Squink actually places 1206s extremely accurately every time. So we encourage users to kind of work with that packet size. We can do 0603s. We theoretically could do 0402s, but it's theory. We have to essentially use very small, tiny tips. As Squink evolves, this may be possible. Now we're placing our SOT23 packages, and it places it perfectly. We'll show you a zoom up of those files in a second. And now we're working on our 280 ohm resistor, and this is only a quick 90-degree rotation. It might have to make an adjustment. It doesn't. In places, but it did make the correction, so the part is placed exactly where it should be. And our final part is our 100K resistor. Our little green goblin that eats up all the power when the when the circuit is not when the phototransistor is not seeing any light, or when it is seeing light. All right. Now it's made a few adjustments to make sure that the transistor was aligned perfectly, and brilliant! Placed it right in the right spot. So that's a 5 out of 5. Not bad. Awesome. Okay, so we can go to the heat step. So, as I said, I want to make sure that all the glue is essentially cured. So when I go to the heat step, it's going to ask me first to remove the pick and place head, which is like that. And then Squink is going to ask me how hot I want to get it. Now, I'm curing a 2-part glue, and you can run it at around 90 degrees for 20 minutes. You can run it for 20 minutes, and that should be enough. I might run it a little bit longer, because I want to make sure that glue is nicely cured, and it shouldn't damage the components. I mean, these are components that are designed to run up to 217 degrees if you're doing reflow and things like that, so no problem. We're more concerned about the paper substrate that we're using. and the tape as well. But it should be fine. It shouldn't curl. It shouldn't expand or warp or anything like that. I did make a mistake and not place the battery holder. Now we can't pick and place the battery holder, so we're gonna have to take a quick pause and find, here it is. I gotta make sure that I place this guy. Hasn't reached temperature yet, so I have an opportunity. Now that's a positive, the anode's on the bottom, cathode's on the top. So I want to place this guy right here. Voila. And there we are. In about 25 minutes we should have a working circuit. I'm going to stop this video and then I will show you some short clips of it actually finished. Okay, so here's the completed circuit. Basically, I took it off the heat bed and encased it in some acrylic here. And if we take a coin battery, a 3.3 volt coin battery, place it in the case, you can see the LED lights up right there. Now, this isn't just some sort of simple light circuit. It's actually a light sensor. I have a phototransistor in the NPN right here. And basically, under the presence of a lot of light, the NPN gates the power and drives it around the LED, turning it off. So if I take light here, check it out, turns it off. Very straightforward design, and I made it in less than an hour using probably combined cost maybe $2.50. Think about that, 45 minutes and the price of a cup of coffee. And I made a fairly decent light sensor. For an educator, this is a perfect way of explaining how you can, design a circuit. For anyone working in innovation space who wants to experiment on a new design and not have to wait, a week or two to get a board, maybe get 10 boards and only use one, you can simply make a circuit with Squink. So, with that, I'm going to sign off. This is JF from Bot Factory. Please check out our website and go to our store and buy a Squink. Have a good day.